Alright class, today you're going to look at section 8.4, which is transforming quadratic functions. And this is a pretty simple process since we've already transformed functions in other units. Okay, so if I look at my equation y equals ax squared plus bx plus c, which we've looked at multiple times before when graphing, we know that the a is the number in front of my x squared. And so the bigger my a value, the skinnier my graph. And the smaller my a value, the wider my graph. Okay, so if you've got a really big a value, you'll have a really skinny parabola. And if you have a really small a value, you'll have a really wide parabola. Okay, so make sure you got that written down. Alright, so if I look at example 1a, I'm given three equations. F of x equals negative 2x squared, g of x equals 1/3 x squared, and h of x equals 4x squared. And it wants me to put it in order from narrowest to widest, so from skinniest to widest. Okay, and we know that the bigger my a value, then the skinnier my graph. So if I look at my a values, I have 2, you can ignore the negative. I have 1/3, and I have 4. And so we need to pick the biggest a value because that's going to be my skinniest graph. Well, my biggest a value is 4, so I know 4x squared is my skinniest graph. Okay, then I know that my next biggest a value, because I'm ignoring that one, is 2. So negative 2x squared comes next. Which leaves then my smallest a value, which is my widest graph, of 1/3, so 1/3 x squared comes last. Okay, so let's do the same thing then on 1b. I'm given f of x equals 2x squared and g of x equals negative 2x squared. So we're looking at only my a values. So I have 2. And I also have 2 on this one because we ignore the negative. You always ignore your negatives. So then which one of those numbers is smallest? Well, as you can see, 2 and 2 are exactly the same, so it doesn't matter which order you put them in. So I'll just leave them in the order they start at, 2x squared, negative 2x squared, because it doesn't matter when they're the same number. Alright, and we'll do one more. So f of x equals negative 4x squared, g of x equals 6x squared, h of x equals 0.2x squared. Since we're going from skinniest to widest, I need to go from my biggest number to my smallest number. So if I look at my a values, I have 4 because I ignore the negative. I have 6. And I have 0.2. Well, which number out of 4, 6, and 0.2 is the biggest? Well, obviously 6 is the biggest number, so I know 6x squared comes first. Then out of my numbers left, negative 4 and 0.2, well, 4 is clearly bigger than 0.2, so negative 4x squared comes next. And then last is 0.2x squared. That's the smallest a value, so it's my biggest graph. Okay, so that's the first part of what you're going to be doing. The second part of what we're doing is looking at our c value, and up until this point we basically ignored our c value. But the c value does have a purpose. Your c value tells you where you're moving your graph. So it either moves your graph up or moves your graph down on your y-axis. Okay, so if C is positive, your graph moves up. If C is negative, your graph moves down. Okay, so if I look at g of x equals negative 1/3 x squared plus 2. If I'm looking at my c value is plus 2. So I know that that's going to move my graph up or down. Since my c value is positive, I know that it moves my graph up 2 on my y-axis. It's always moving it on your y-axis. So whether it's going up or down, it's always on your y-axis. Okay, so if I do the same thing then for 2b, 2x squared minus 3. Well, my c value is minus 3. Because of this minus, this negative, that tells me that my graph is moving down 3 on my y-axis. Okay, you always have to put the on the y-axis part. Alright, and we'll do one more. So g of x equals negative x squared minus 4. Well, my c value is minus 4. This minus tells me that my graph is moving down 4 on the y-axis. Okay, so that's what you guys are going to be working on today, 549, 1 through 18.